What happens to the brains of people with depression? This video will explore the biological basis of depression and determine what physical changes are happening. Be sure to watch until the end because you will learn if these brain changes are reversible. Even though it only weighs about 3 pounds, the brain is the most critical organ in our body. It controls and regulates almost all life processes like thoughts, memories, emotions, senses, motor skills, vision, breathing, temperature, hunger, etc. Conversely, can our emotions change the brain? We have ups and downs in our life, with our emotions joining the roller coaster ride. We may cry or feel upset for a few days, but we bounce back and continue our everyday life most of the time. However, if you have clinical depression, that is a different story. The feelings of hopelessness and sadness can last for months or years. Scientists have found that persistent symptoms can lead to physical changes in the brain. What chemical changes happen in the brain of depressed people? Here are 2 theories that explain the brain changes at the chemical level. 1. Circadian rhythm. Commonly known as the sleep-wake cycle, the circadian rhythm is critical for our physical and mental health. Serotonin, a neurotransmitter, plays a role in controlling when we sleep and wake up. Let's look at the relationship between the sleep-wake cycle, serotonin, and depression. Sleep. Depressive patients most often have sleep problems. Our sleep has 4 stages. The first 3 stages are non-rapid eye movement or NREM, and the last stage is rapid eye movement or REM. A person with depression has much shorter NREM stages and a more intense REM stage. A study found depressive patients can dream 3 times more than a regular person. During REM sleep, the serotonin levels in the brainstem decrease. So paradoxically, sleep deprivation can lift a depressive patient's mood by shortening REM and hence increasing serotonin levels. Antidepressants, like selective serotonin reuptake inhibitors or SSRIs, also improve mood by increasing serotonin levels. Light therapy. Light has effects on serotonin levels too. Researches show light deprivation leads to lower levels of serotonin. So light therapy can help produce more serotonin and improve depression in the same way as the SSRI antidepressants. Currently, severe cases of depression can benefit from the combination of light therapy, sleep deprivation, and sleep phase advanced therapy. 2. Monoamine hypothesis of depression. Monoamines are neurotransmitters that include serotonin, dopamine, and norepinephrine. Serotonin is responsible for mood and behavior regulation, sleep, and digestion. Norepinephrine for the fight or flight response, and dopamine for movement, pleasure, and motivation. A deficit of these neurotransmitters may cause depression. Serotonin. Research shows that serotonin may change emotional processing biases. For example, high serotonin levels make people see more happy faces, and low levels lead to more negative responses. So serotonin indirectly affects our mood. Dopamine. In a depressed person, there is decreased activity in the nigrostriatal path, one of the major dopamine pathways in the brain. Lab findings also show decreased metabolic products of dopamine in cerebrospinal fluid in depressed patients. Norepinephrine or noradrenaline. There is evidence of decreased norepinephrine metabolism, production, and transportation in the brain of depressed patients. It indicates the dysfunction of the central noradrenergic system. In addition, brain autopsy of depressed suicide victims shows decreased neuronal counts in the locus coeruleus, which produces most of the norepinephrine. In conclusion, the monoamine theory does explain how some antidepressants, like SSRIs, work. They increase serotonin levels. However, depression is a more complex disorder than a simple chemical imbalance. What are the differences between the depressed brain and the typical brain? Numerous studies show that the typical brains are quite different from people with depression. 1. Brain shrinkage. Some regions of the depressed brain can decrease in size. Let's take a look at 3 structures. Hippocampus. The hippocampus plays a vital role in learning, memory, and spatial navigation. It is an integral part of the limbic system. Persistent depression can affect the chemical balances in the brain, which makes the neurons in the hippocampus shrink. As a result, the patient can have memory loss and difficulty concentrating, making learning new things impossible. They may also have trouble completing familiar tasks, such as keeping appointments or finding the right place. The loss of function exacerbates the feeling of hopelessness, guilt, and anxiety. Thalamus. The thalamus is an extensive communication network between the cerebral cortex and the midbrain. Its primary function is to relay motor and sensory signals to the cerebral cortex and regulate sleep, alertness, and wakefulness. A shrunken thalamus has trouble maintaining a healthy sleep pattern. Prefrontal cortex. The prefrontal cortex is the section of the frontal cortex that lies at the very front of the brain. Its functions include focusing attention, predicting the consequences of action, and anticipating events in the environment, impulse control and management of emotional reactions, planning for the future. Reduction of these areas makes people impulsive and easily agitated. It may also lead to trouble thinking, memory loss, and difficulty making decisions. 2. Brain inflammation. Studies have found that major depressive disorder is linked to brain inflammation. The longer an individual has been depressed, the higher level of inflammation in the brain. However, it is not sure if inflammation causes depression or the other way around. The amygdala, which influences pleasure or fear, is the brain area most affected. During a depressive episode, the inflamed amygdala becomes enlarged and very active. The individual may experience disrupted sleep patterns, social anxiety, restlessness, guilt, panic, self-blame. Furthermore, brain inflammation can also cause brain cell death. The effects are twofold. First, the brain will shrink more and form fewer new connections. The result is the entire brain ages faster. Secondly, neurotransmitters become less active, causing the brain operation to slow down. This change makes people's thinking slow and fuzzy. They feel fatigued and move slowly. 3. Structural differences. Recent research suggests that large-scale brain networks are involved in depression. Too much or too little activity in these networks may play a role in the onset of depression. We will look at the central executive network and the default mode network. Central executive network. This network is involved in high-level cognitive functions such as working memory, problem solving, decision-making. During depressive episodes, this network shows lower activity levels. Because this network is crucial for everyday life activities, people with depression can have difficulty in basic activities like test-taking and decision-making. Default mode network. The default mode network is usually active when the mind wanders and thinks about social situations. According to studies, this network shows a higher activity level in people with depression. The effects are increased emotional reaction, tendency to get stuck in negative, self-focused thoughts. 4. Oxygen restriction. Depression has been linked to hypoxia, reduced oxygen in the body. When the brain doesn't get the oxygen it needs to function properly, brain cells can die. At first, individuals might experience lack of attention, poor judgment, temporary memory loss, trouble moving parts of the body. If the lack of oxygen continues, more severe the symptoms can develop, such as coma, seizure, brain death. Oxygen treatments, like hyperbaric oxygen chambers, can relieve symptoms of depression. Can we reverse the brain damages in depression? All hope is not lost. The brain shrinkage in depression is due to the weakened dendrites, not the loss of neurons. So the dendrites can regrow, and neurons re-establish new connections. Hence, brain damage can heal. The damages are especially profound in recurrent and poorly treated depression. It is essential to treat depression early, particularly in teenagers and young adults. Some antidepressants and cognitive behavioral therapy may help the brain reduce inflammation caused by depression, form new neuron connections. Exercise can also help improve the hippocampus structure in people with depression. A quick reminder, this video is for information only. Please seek medical advice from appropriate healthcare professionals. If you like the video, give it a thumbs up and share it with your friends. Comment below to share your understanding of changes in the depressed brain. Please subscribe to our channel. Your support means everything to me.